Okay, hi there. We're going to do some factorizing of quadratic expressions to start with, just to remind ourselves of how to do that. And then we're going to go through some solving quadratic equations using factorizing. We're going to remind ourselves of what dots ones are, and also what to do if if it doesn't factorize. So we're going to use the formula, and also just for fun, we're going to do some factorizing when the number in front of x squared is greater than 1. We've got a lot of stuff to cover today, basically. So what I first of all want you to do is just remind yourselves of straightforward how to factorize straightforward quadratic expressions. There's a link in the bottom right if you're not sure to the video where I cover this in greater depth. But hopefully, if you're on this video, you should remember how to do that. And there's also, I suppose, there's a written thing up here that might help you. So pause the video, factorize these, please, and then we'll rattle through those and move on. Off you go. Right, okay, so first things first, if we're going to factorize, we need some factor pairs of 24, which could be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Now I need one of these pairs, needs to add up to make 11, and the pair that's going to do that is this pair here, the 3 and the 8. So they're the ones that are going to go in the brackets. They're both positive, so it's 3 plus 8, and it's x plus 3 and x plus 8. Doesn't matter which way round they go, to be fair. Could be x plus 8, x plus 3, but it's double brackets with an x in each. Yep. Okay, straightforward. You know, as I say, if you are struggling with that, you might want to go and have a look at the previous video. This is just a kind of a recap, just check that we know what we're doing. Right, negative 24. Factor pairs for 24 could be, again, 1 and 24, 2 and 12, 3 and 8, or 4 and 6. But we need to make negative 24. Now that could mean the first number in each pair is negative. Now only one of the numbers in each pair can be negative. It can't be both, because otherwise negative times a negative would make a positive here. Now I need to make negative 5. I don't think any of those pairs are going to work, because it could also be the same pairs but with the second number of each pair as negative. So it's a good idea to actually write them out again with the second lot as negative and the first lot as negative. Two sets of them. And actually, the pair that I want this time is going to be 3 and negative 8. Negative 3 and positive 8 won't work because it would make positive 5. But 3 and negative 8 will work. And those are the two numbers that go in my brackets. The 3 is positive. Oops. The 8 is negative, so it's x take away 8. There. Do you know, that looks a little bit scrappy, so I'm just going to redo that because I don't want to leave it looking quite that bad. So let's go back to the pen. There we go. So it should be x plus 3 and x take away 8 because it was a negative 8, yeah? And when you expand that, you would get x squared minus 5x minus 24. Same thing again then. So factor pairs for 20 could be 1 times 20, 2 times 10, 4 times 5, and those are all the factor pairs. But we need to make negative 20, so it could be the first number in each pair, or it could be the second number in each pair. But one of those pairs will add together to make this. Now, negative x is really negative 1x, isn't it? We just don't usually write it because we're lazy people. Which one of these pairs makes negative 1? Well, 4 take away 5 makes negative 1. So those are the two numbers that go into my brackets. And it's positive 4 and negative 5. So x plus 4, x take away 5. I say, if you're struggling with those, you might want to go watch the video again. Otherwise, let's shift on. Firstly, a quick reminder of what dots are. And this is difference of two squares, because these ones are tricky and they will come up. I almost guarantee, in fact I will guarantee, that in your GCSE at some point you will get one of these questions come up. Difference of two squares. Now, x squared is clearly a squared number because it's something squared. Whatever x is, if I square it, it becomes a square number. And 9 is a square number just because it is. It's a good idea. You really need to remind yourself of your square numbers. 1 times 1 is 1. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. You need to get to know these square numbers. If you do, it makes your mathematical life a whole lot easier. 9 nines are 81, 10 tens are 100, and so on. You know, all the way up to, ideally, about 15 squared. Right, and the way you factorize these is this. You do open up the double brackets with x in, and you do the square root of 9. Now, square root of 9 is 3, and you put positive 3, and you put negative 3. And believe it or not, if I expanded this out, I would get x squared take away 9. I'll just show you briefly why it works. Because if you expanded, you get x squared, you'd have negative 3x, you'd have a positive 3x, and 3 times negative 3 is negative 9. But look, two of these things cancel out. The negative 3 will cancel the positive 3, and you're left with x squared take away 9. Right, it's a tricky one to do. If you can't remember how to, that it's a difference of two squares and how to factorize that, it can make it a bit tricky. I've already said they're square numbers. I've already said it's a minus. So I really don't need to go over that again. So if you had x squared take away 49, well, the square root of 49 is 7 because 49 is a square number, so it's difference of two squares. And you do x plus the 7. You do x minus the 7. Again, it doesn't actually matter which way round they go, as long as one is plus, one is minus. And lastly, x squared take away 36. 36 is a square number, and the square root of it is 6. So if you want to factorize these, you put x plus 6. You do x minus 6. Yep. Difference of two squares. So just spot them. Just quickly have a quick go at doing those three. Pause the video, write them down. When you're done, unpause, and we'll see what we've got and move on. Okay, unpaused. Well, the square root of 4, because 4 is a square number, is 2. So if you were factorizing this, it would be x plus 2. It would be x take away 2. This one, 144, is a square number. It is the square of 12. So we will put x plus 12. We will put x minus 12. And lastly, 81 is also a square number, and it equals, the square root of that is 9. So we do x plus 9, and we do x take away 9. Right, hopefully you got all three of those right. It's important to note that it has to be subtract. Difference means subtract in maths. And so it has to be subtract. If it's a plus, then it just won't work. Right? Okay, let's move on. Let's solve these quadratic equations by factorizing. So we're going to solve, right? So actually, this is still going to be kind of recapping what we've done in a way. Now, solving means to find the value of x that makes the equation work. Now, we always have them equaling 0. This is really important for factorizing and solving quadratic equations. So they must equal 0. But the first thing is actually how we did it before, because it does say by factorizing. So let's find our factor pairs of 12. So 1 times 12, 2 times 6, 3 times 4. And what pair adds up to make this coefficient of x, this number touching x? Well, that's 3 and 4. So if I was factorizing this, I would have x plus 3. I would have x plus 4. And it equals 0, because this is still equals 0. All we've done is factorize the left-hand side into two brackets. Now, I'll show you why we're going to do that. Now, look, we have got two things times together. Basically, we've got the first bracket. Let's just think of that as A. And the second bracket is B. And when I times those together, I want them to equal 0. Now, the only times that this is going to work is if either A is 0, so we're doing 0 times B is 0, or if B is 0, so A times 0 is 0. One of these has to be 0 for it to equal 0 when you multiply them, because the only way of making 0 by multiplying is if you're multiplying by 0. Try it. You try and find two numbers that when you multiply them together, it equals 0 when one of them isn't 0. It doesn't work. Okay, so that's what I'm going to do. I'm going to make the first bracket equal 0. Now that's going to happen. This is quite a nice easy solve here, isn't it? When does this happen? Well, that happens when x has the value of -3, because that -3 plus 3 equals 0. You just solve this tiny little equation. Just write out the expression, so x plus 4 for the second bracket equals 0, because that's what you want it to do. and solve it. We'll take away 4 from both sides. You get x equals -4. So the solution to this is x equals -3 and x equals -4. It has two solutions. Quadratic expressions often have two solutions. Sometimes the solution is the same, so it might be the same number for both, in which case, in a way, it only has one solution. And other times it has these things called complex numbers, but let's not go there because they're fun but icky. And they're not in GCSE, so let's ignore it. Okay, so we have two solutions. Right, let's try it again. So first of all, just factorize. Well, it could be -1 and 24. We just find those factor pairs for 24. 3 and 8, and of course 4 and 6. And which pair adds up to +5? Well, I don't need to do my second pair where the other ones are negative, because I can already see that I've got the pair I want. So I can factorize my expression, so x minus 3 and x plus 8, because -3 and 8 makes +5, remember? Just like the starter. That equals 0, because this equals 0. And then what do? I make each set of brackets equal 0, and I do one at a time. X minus 3 equals 0. I'll solve this, so add 3 to both sides. That's only going to happen when x has the value of 3. So you just write the bracket equals 0, just solve it. That's going to work when x is 3. So that's one of my solutions. X equals 3. And then write the other bracket out and solve that. So take away 8 from both sides. X equals -8. So that's my other solution. You know, just to recap, what this means is if I put x as a value of 3, this equation will equal 0. It will work. Or if I make x have the value of -8, it will also work and equal 0. Okay, that's what we mean by a solution. Look at this. What's this? This is dots, isn't it? Difference of two squares. Right, 16. What's the square root of 16? Well, it equals 4, which means that this will factorize to x plus 4 and x minus 4. And it equals 0 because that equals 0. And then to solve it, I want each bracket in turn to equal 0. Well, this will happen. Well, take away 4 from both sides. So x minus equals -4, sorry, is one solution. And x minus 4 equals 0. Now make the second bracket equal 0 as well. Add 4 to both sides. That will be +4, right? So that's my other solution. X equals -4 or x equals +4. So each of these had two solutions, one for each of the two brackets. Okay, hopefully you get the idea. I want you to solve these by factorizing. Pause the video, factorize them, solve it, tell me what the values of x would be to solve these equations. Off you go. Okay, right, factor pairs for 6, well 1 times 6 or 2 times 3. Now, which one's going to make 5? Well, that would be the 2 and the 3. So if I factorize this, it will be +2 and x plus 3. Yep, so that's factorized. Then I want to solve it, so I need to make each bracket equal 0. Now that's going to happen when x equals -2, because -2 and +2 make 0. And I want to make this bracket equal 0 as well. And that's going to happen when x equals -3. So my two solutions are x equals -2 and x equals -3. Those will make this equation equal 0. Right, hopefully getting the idea now. Right, factor pairs for 11, so 1 times 11, but it's negative, so one of them must be negative. And, well, that's it, isn't it? Or the other, it could be the other way around, could be 1 and -11. Sorry, I had to have a little cough there. And let's have a look. So we've got 10, but it's +10. So which pair makes +10? It's this one, because -1 and +11. So there's my two numbers that I need in my brackets, and that's a +11, isn't it? Equals 0. So I factorized it. Now I need to solve it. make each bracket in turn equal 0. Now this first one's going to happen. Let's add 1 to both sides. That's going to happen when x is positive 1, because 1 take away 1 is 0. And the second bracket is going to equal 0. Let's add 11 to each. Oh, sorry, take away 11 from both sides, haven't we? So it's minus 11. X equals 1. X equals minus 11. And you might have already noticed that the solutions tend to be the opposite signs of these. So instead of positive 2 and positive 3, it's negative 2 and negative 3. Instead of negative 1, positive 11, it's positive 1 and negative 11. Now, you can kind of think of it like that, but there are examples later on that will be harder, and that doesn't quite work. All right, but you can think of it like that for these simpler ones, but I tend to do it the long way round, so we know what we're doing. Okay, right, this last one. So factorizing, we do 1 times 21. Oh, but look, this is negative. Remember what this means. 1 times 21 makes positive 21, but I need this to be negative. Or also, it could be 3 times 7, of course. Or 3 times 7, both positive, makes positive 21, but doesn't make negative 10. Look, what this could be, the other way of making a positive number is to times 2 negatives together. And that's what's happened here. We've times negative 7 by negative 3 to get positive 21, but when you add them together, you get negative 10. So those are my two numbers to go in my brackets, negative 3 and negative 7. Okay, each bracket needs to equal 0. Now that's going to happen when x is positive 3, so that's one solution. And this one is going to happen when x equals positive 7. So those are the three solutions to those. Right, really particularly well done if you noticed that last one with the double negative there. Well done if you got the others right though. Let's move on. Right. Okay, we're going to cover, I say we're covering some extra ground here. Look, what about when a is greater than 1? Now what I mean by a is I mean the coefficient of x squared. Posh word for the number touching x squared. Because actually our quadratic equations always look a bit like this. Something x squared. Now usually that's been 1 up to this point, but now we're going to have something a bit bigger. And then b is the number touching the x, and then the c is the number on its own. So look, what values have I got here? Well, a is equal to 2, b is 13, and c is 15. Okay, I have a method for this. This is how it goes. Now, I've used various methods in the past. This is the best one that I've found so far. I think it's the clearest. Firstly, multiply together the two outside numbers, the coefficient of x squared and that number on its own. Basically like a and c. Multiply a and c together. 2 times 5, oh sorry, 2 times 5. 2 times 15 is 30. I can't even read numbers now. And once you've got that number, you just find your factor pairs of that number, just like you did before, except this time it's with 30 instead of 15, right? So factor pairs for 30 would be 1 times 30, it could be 2 times 15, it could be 3 times 10, it could be 5 times 6, and there's all my factor pairs. I want the pair that adds up to 13, so that's still the same, which is this one. And so, now I'm going to do this in a different colour, because this is not equivalent to my original expression, or I would put it in another colour if it let me. I'm going to put it in red, I think, for now. I'm going to write out two brackets with those two numbers in, but instead of putting x, I'm actually going to put this number here. I'm going to put that. I'm going to put 2x. And this one I'm going to put 2x as well, plus 10. So I use the 2x, the start of my equation here, but the two numbers that I've done before. So it's really similar to what we've done before, except I've now got 2x plus 3, 2x plus 10. Now that, if I expanded it, I am not going to get my original equation. So this is not right yet, but we've got a really easy step to get to it. Because if I did 2x times 2x, I get 4x squared. That's clearly not right. So what I need to do is do some simplifying. Now this bracket, is there anything that divides 2 and 3? Other than 1, which isn't going to help. No, there isn't. But this one, 2 and 10, can both be divided by 2. So I do that. Now my first bracket hasn't changed, that's still 2x plus 3 because that wouldn't simplify, but this one will. 2 divided by 2 is 1, so that's now just 1x, or rather x. 10 divided by 2 is 5, and that is my answer. Okay, that is it factorized. That's how to factorize when a is greater than 1. Multiply together the outside numbers, find factor pairs of that, find the pair that adds up to b, that coefficient of x, just like you did before, and then write it out in brackets, but use, in this case, 2x squared, whatever that is at the start of your equation, and see if you can simplify the brackets. Right, it's a much, trust me, it's a much easier version than the other, the other way of doing it. All right, and that is it. That is factorized. Then you solve how you did before. Let's start with this bracket first. This one's slightly more straightforward. X plus 5, I want that to equal 0. That's going to happen when x is equal to negative 5. So that is one of my solutions. But the other one is going to be slightly trickier. Now 2x plus 3 equals 0. Right, I want to solve that. So the first thing you're going to do is take away 3 from both sides. So 2x now equals negative 3. And then you need to divide by 2. So x equals negative 3 over 2. I ran out of space a little bit there, but x is equal to negative 3 over 2, which is actually negative 1.5. Right? So that's where these can get a little bit harder. So you always put them in like that. You know, do 2x plus 3, and then, you know, simplify it from there. You know, make that equal 0 and then solve. So make the bracket equal 0 and then solve is what I'm saying. Yeah? Okay, let's move on. Oh yeah, there's a description down the bottom there, which I'll clear up there. So you multiply together a and c. You find factor pairs of that number. See which pair sums to the coefficient of x, and then write in double brackets and simplify where possible. Yep. Let's do that. Oh, no, let's come back. There we go. So, let's do 5 times by the negative 12. Oh, that's negative 60. So multiply a and c. Find factor pairs for that number. So I need factor pairs for negative 60. Now 60 has a lot of factor pairs. 1 times 60, 2 times 30, 4 times 15, 5 times by 12. It has 6 times by 10. And thankfully, that is it. But I need to make negative 60, so it could be that the first numbers are all negative. Now, do I have a pair that already adds up to positive 4? Yes, I do. Thank goodness. I haven't got to write them all out again with the second one negative. No. Negative 6 plus 10 makes positive 4. If you don't believe me, try it. Minus 6, add 10 makes positive 4. So, write out that in a bracket. Now remember, this isn't correct yet, but this is a way of getting to the correct answer. So let's start with that number there. So instead of x, I'm going to put 5x. And I'm going to put my other two numbers in. So minus 6, and I'm going to do 5x plus 10. Now, have a look and see if I can simplify either of these. Can I, or before I change colour, stick with red. 5 and 6. There's nothing that divides both 5 and 6, except for 1. 5 and 10, yes, both of those divide by 5. So that's what I'm going to do. Let's go back to my blue pen. Now the first bracket hasn't changed, so it's still 5x, take away 6. The second bracket I can divide by 5. 5 divided by 5 is 1, so it's just x. 10 divided by 5 is 2, so that becomes 2, which is 0. Yep, and then we're going to do some solving. So you write out your bracket, so 5x take away 6 equals 0, and solve it. So add 6 to both sides, so 5x equals 6, and then divide by 5, so 6 over 5. Yeah, which actually equals 1.2 if you're writing it as a decimal. Then make the second bracket equal 0. That's a bit easier, isn't it? Because all I do is take away 2 from both sides. So x equals negative 2. So my two solutions are x equals 1.2 and x equals negative 2. So multiply together the outside numbers, find factor pairs for that number, find which pair adds to make the coefficient of x, that number touching x, write it in brackets, but then see if you can simplify either or both your brackets. That equals 0, and then you can solve from there. Okay, looks like a long method, but trust me, it's a much better method than the others. Okay, right, there's some questions for you to do. There's the pause button. I want you to do those questions and then unpause when you're done, please. Off you go. Okay, we have unpaused, and here are your answers for these, because it does take a long time to do these. So if you need another explanation, you can go back and watch the previous ones, but these are the answers for those 4 questions, and then I think we will probably stop there because that's been a lot of work today. Well done. Here are the answers. Right, that's the factorising for that bracket. So the answer is minus a third, and x equals minus 4. Here's the factorising for this one. So 2x plus 1 and 3x plus 1. So that simplifies to x equals minus a third and x equals minus a half. Doesn't matter which way round you go, you know, they're both solutions. Okay, these brackets, 3x minus 4 and x plus 5, which has solutions x equals 4 over 3 and x equals minus 5. And lastly, tricky one, this one because it's got a big number, 4x minus 3 and 5x minus 1, which the answers are x equals 3/4 or 0.75 and x equals 1 over 5, 1/5 or 0.2. Right, that is definitely enough for today. We will leave doing the formula for next time, okay? So well done on doing those. You've done brilliantly. I shall see you next time.